remembering that when you see that inequality symbol, there's differences in the graph. So it does give an example. Here's an inequality versus here's the corresponding or related linear equation. But two main differences is when you actually graph the line, you have to pay attention to whether it should be a solid line or a dashed or dotted line, however you think about that. And then you also have to shade one part of your graph. So if your line divides your coordinate plane into two parts, you're shading one of the two parts. And the shaded part is what represents the solution. So remember, inequalities have infinitely many solution sets. The graph is the visual representation of the solution set. So you're shading all of the ordered pairs. In this case, that would be solutions. So just to summarize here, I don't want to read through this whole thing. We're first going to look at, so the graph of the line, the related equation or the corresponding equation is the boundary, and it would be, I'll just list this below. You will use a dashed or dotted line when you just have less than or greater than. That's kind of the equivalent of having an open circle on a number line. So that means the ordered pairs that are on the line are not actually included in the solution set. And then it is a solid line if you have the equal to with it, because then your x and y can equal what is on the line. So all of the ordered pairs on the line would actually be solutions. And then we'll talk about how to determine which side to shade. So we'll look at example 1. We're graphing x plus 4y is greater than 2. So I would first get this into slope-intercept form to graph. So solve it for y. So if I subtract x from both sides, so 4y is greater than, I'm getting it into the mx plus b, so I'm going to put the negative x first and then plus 2. And then divide everything by 4. So if y is greater than, I'm going to write this, if I have negative x over 4, that's the same as negative 1/4 x. Just make sure you're not writing it as negative 4x, you're not multiplying by 4. And then plus 2 over 4 is 1/2. I could put 0.5 for that if you'd like, but always keep the slope as a fraction. And then you're graphing this boundary first. So graph this just like you would a normal line. So we haven't formally as a group or as a class talked about graphing in slope-intercept form. But if you were to graph in slope-intercept form, what do you want to plot first? The y-intercept, which the y-intercept is what in this, for this line? 1/2. So that's your b. So on your y-axis and your b, this sometimes confuses people when b is a fraction because you get into the habit of rise over run for your slope. So you do just go up to where 0.5 or 1/2 would be on the y-axis. And then what would I do from there? Carter? Down 1 over 4. Your slope is negative 1/4. So from the y-intercept, down 1, right 4. To put another point, and you can keep going down 1, right 4. Or you can do the opposite. You could go up and to the left. You need at least 2 points plotted to actually draw your line. And then before you draw in your line, I know I didn't have you pick up rulers, so just do your best to draw a straight line. But before you draw it in, determine if it should be dashed, because normally we're used to drawing it in solid. So should this be solid or should it be dashed? Dashed. And make sure, because you are shading, that you do extend it all the way through either end of the coordinate plane, and that way you can clearly see it's divided into two parts. So we can shade one of the two parts. Anyone remember how to determine where to shade then? So we need to shade one of the two sides. Anyone remember how you determine which side to shade? Hannah?
You put in 0 for both line, as soon as you see 0, makes it like you see if the inequality is true.
Yes, so you can test a point. And the easiest one to test is 0, 0. It doesn't have to be 0, 0, but I usually use 0, 0 like Hannah did. So the only time you cannot use this is if your line actually goes through it. So you cannot test a point that is actually on your line. So for example, I could not use 0, 1/2, but 0, 0, my line doesn't touch, so I can use it. If it did touch it, I could pick any other point that my line doesn't go through. And you're putting those values in for X and Y. I would put them into the original just in case something got rewritten incorrectly here. So I would always put them back into the original up here. So I would have 0 plus 4 times 0 is greater than 2. And then as Hannah said, determine if it's true or false. So if I simplify this side, 0 plus, this would also be 0. So this side is just 0 is greater than 2. I know that is not true. 0 is not greater than 2. This is false. So if I look where 0, 0 is, 0, 0 is underneath my line. So because when I plugged it in, it was false, I want to shade the other side. So I would be shading everything above my line. If I substituted in 0, 0 and it was true, then I would shade the side 0, 0 was on. So every ordered pair, any ordered pair in this shaded region is a solution. Okay, questions there? I know this is review. Okay. Then I have another linear inequality example, but one that we have to set up the inequality. And then I also just wanted to review with you a method for graphing aside from the slope-intercept form. So this one says, a recreation center offers various 30-minute and 60-minute art classes. The recreation director has allotted up to 20 hours per week for art classes. So part A says to write an inequality to represent the number of classes that can be offered per week, and then to graph the inequality. So if I'm writing the inequality, I am writing a linear inequality. I should have two variables, which my two variables are my two different classes, my 30-minute versus my 60-minute. So I'm going to let X represent my number of 30-minute classes. And then Y can represent my number of 60-minute classes. So your two variables again, it does tell you representing the number of classes. So I know the number of each class would be my variable, but I wouldn't necessarily know ahead of time. But I know how long each type of class is. So I have my two classes, how long they are, and then I know that the director's allotted up to 20 hours per week. So one thing with this, because the classes are in minutes and the allotment is in hours, make sure before you write your inequality that the measure of time is the same. So you could change the 20 hours to minutes, but to avoid a larger number, I would actually probably change these into hours. So I know that 30 minutes is half of an hour, and then 60 minutes is 1 hour. And that way everything's in hours. Anyone have an idea of what the inequality is? Bless you. If you've looked ahead at it. Okay, so we have per week, we're totaling our classes, and we know the allotment can only be up to 20 hours. So if it's half of an hour per every 30-minute class, so 1/2 x, half of an hour for every 30-minute class, plus 1 hour for every 60-minute class, which is y, so either 1y or just y. I'll put a 1 there for right now. That sum, that total amount of time, can only be up to 20 hours. So I'm going to have an inequality here. I shouldn't have an equal sign, but then I'll have 20. Anyone know which inequality symbol I would have? Alexis? Less than or equal to, yes. So it could equal 20, or it has to be less than 20. We don't have more than 20 hours to work with. So when it says write an inequality, this is my inequality. And that's different per question. So you kind of saw my thought process for working through that one. And then it says to graph this. Now, I certainly could get this into slope-intercept form to graph the way that we graphed the first one. I just want to remind you of another method we have for graphing that sometimes works. The values in this one are really nice, but the method I'm going to show you sometimes works if you have larger numbers. So notice I also didn't put just the standard coordinate plane, because with this type of example, we're really just focusing on that first quadrant where x and y would be positive. So before I label anything on here, I just want to review with you that you can graph using intercepts, the x and y intercepts. And sometimes, like I said, for these problems, that's a little bit nicer to graph, because then you can also get an idea of what you should scale your x and your y axis by. So if I were to find, and when you find the intercepts, you are thinking of this as an equal sign, not as an inequality. But if I were to find the x-intercept, because we did cover this in this chapter, anyone remember from an equation how you find the x-intercept? We haven't talked about it since you would have seen it on your quiz, Liam. Yep, you put 0 in for y. So I don't have to change anything, I just put 0 in for y. Again, think of this as an equal sign. So I would have 1/2 x, the plus 1 times 0, this will be 0. So then I would have equals 20, and then I would solve for x. And how do I solve this for x? Divide by 1/2, which is the same as multiplying by 2. So I can multiply both sides by 2. So x, my x-intercept is 40. So I know when I am labeling my x-axis, I want to be able to see the number 40 on there. And then to find the y-intercept, I just do the opposite. I put 0 in for x, and I solve for y. So the 1/2 times 0 would be 0, meaning I would just get 1y, or y equals 20. So that's my y-intercept. So if I just would have started out kind of labeling my x and y axis, because again, this is 10 by 10, just scaling by ones, I actually wouldn't have seen either intercept on my graph. So if this is 0 here, what could I scale x by so that I make sure 40 is on there? Could scale it by 10s. 5s also would have worked. So that's where you might have a slightly different looking graph. And I am going to label to my x-axis. This is my number of 30-minute classes. And then what could I scale the y-axis by to make sure I see 20? Could do 5s. 10s would also work. 2s would actually work. You'd have 20 at the very top if you scaled it by 2s. And my y-axis, I know my stuff is kind of getting together here, but this is the number of 60-minute classes on the y-axis. So then when you graph using intercepts, just remember these are two separate points. So x equals 40, this is a point at 40 on the x-axis, or the ordered pair 40, 0, and then my y-intercept of 20 is my point at 20 on the y-axis, or 0, 20. And then I would just draw a line through them, and should that line be solid or dashed? Solid. Okay, so then you end up with that triangle there, or this area that's outside of it, and you do need to shade one of those two parts. So again, if I were to test, since my line isn't touching 0, 0, I can test 0, 0. So if I were to put 0 in for both x and y, 1/2 times 0 is 0, plus 1 times 0 is 0, so this left side is 0, is less than or equal to 20, and that is true. So I would want to shade towards 0, 0, meaning it's this triangle that is shaded. Okay, and then it says for part B, can the recreation director schedule 25 of the 30-minute classes and 15 of the 60-minute classes during a given week? And to explain. Anybody have a yes or no answer for that? And then why? Braxton? Okay, so if that would mean, yeah, x is 25 and y is 15. So if we have 1/2 times 25 plus 15, we could see if it's less than or equal to 20. So this would be 12.5 plus 15, which is actually 27.5, which would not be less than or equal to 20. So right method of checking, but this means we actually could not schedule that. So we could say no, because this would total 27.5 hours. Okay, but one way to check is to substitute in, you have an x and a y value. Anybody else know another way you could check? Eva? Yes, so this would be the ordered pair, 25, 15. So if I plotted 25, 15, that is right here. It is not in the shaded region, meaning it is not a solution to that inequality. So you could also give another reason, since you have the graph, you could say no, because the ordered pair 25, 15 is not in the solution region of the graph. Okay, so realizing any ordered pair that's actually on the line or in that shaded region, those are your solutions. Anything outside of that is not a solution. Okay, any questions there? Okay. Then the last example is, like I said, putting two things you've done now together. So we've spent time graphing absolute value equations. We just reviewed how you graph an inequality. Yes, it was linear, but graphing any inequality is the same idea, just making sure that your boundary is either solid or dashed, whichever it needs to be, and then you shade. And how you test a point and shade doesn't change. So just putting those two things together now for absolute value. Again, absolute value graphs should have what shape? A V. So I know that this should be a V because when I look at this inequality, I see absolute value bars. I should not just get a straight line for my graph. Now, when you're graphing absolute value, because this did not come up with the equations that I had you graph, notice the y is not alone. So get the y by itself before you graph. So in this case, I'd want to subtract 4. So I'd have y is less than or equal to the absolute value of x minus 2. The minus 4 is on the outside of that. In looking at this, just because we've talked about transformations, how would this graph be transformed from just the absolute value of x? What transformations are happening with this absolute value graph? It goes down. Down how many? Down 4. And what else? It's going to the right 2. So if you think about this, normally the shifts that are, or the translations, I should say, that are left, right, up, and down, that's what's affecting your vertex of your absolute value graph. Normally the absolute value graph has a vertex at 0, 0. Now the vertex is being shifted to the right 2 and down 4. So now another way you can think of to find where your vertex is to look at your transformations. My vertex should be at the ordered pair 2, 4 because of those translations. But you can still find the vertex the other way I had showed you, or the first way I had showed you, by taking what's in the absolute value bars, the x minus 2, and setting it equal to 0. So you would get the x value 2 for your vertex. When you substitute that in, you should get 4. Then I'll just substitute in a couple of values on either side. So if I substitute in 0, 0 minus 2 is negative 2, but the absolute value is positive 2. Minus 4 is negative 2. Yes, thank you. I was going to say that's not right because it should open up. So thank you. It should be negative 4 because of the down 4. And then if I substitute in 1, 1 minus 2 is negative 1. Absolute value is 1. Minus 4 is negative 3. And then I should see y values repeated as long as my vertex is correct. Plug in 3. 3 minus 2 is 1. Absolute value is 1. Minus 4 is negative 3. 4 minus 2 is 2. Absolute value is 2. Minus 4 is negative 2. And then when I graph this V, should it be solid or dashed? Solid. And make sure that you are extending all the way through, again, since we are going to have to shade. Because what you end up getting is you'll get a part that's kind of in the opening of the V or above the V, and then below or outside of the V. So we have either up here or down here. We can still test a point to determine where to shade like we did before. So if I were to test 0, 0, again, I always go back to how the inequality was originally written. So if I put in 0 for x and for y, I would get positive 4 on the left side is less than or equal to. And then when I plug in 0 for x here, I get 0 minus 2 is negative 2, but the absolute value is positive 2. And is that true or false? False. So where do I want to shade? Above or below? Below, yes. So 0, 0 is above, but when I substituted an in, it was false. So I don't want to shade 0, 0. I want to shade away from it.